Hi, my name is YU-KUAN. Today I will demo my LeafLab application. First, I log into my EC2 instance and connect to RDS PostgreSQL. I run select all from files, and we can see there are 9 rows of file metadata. Next, I open the web client and upload one image. The upload succeeds. I go back to PostgreSQL and run the same query again. Now there are 10 rows. The new rows S3 key shows the S3 object path. In the S3 basket, you can see the image we just uploaded. So how it works? When I click upload, the client asks the backend for a pre-signed URL, and then upload the file directly to S3 from the browser. After that, the client calls the API to commit the metadata to RDS. In the browser dev tool, you can see the network calls. First, the client asks the API for a pre-signed upload URL. Then the browser uploads the file directly to S3 using that URL. After the upload, the client calls the API to commit the metadata to RDS. When I click download, the client requests a pre-signed get URL and then download the files from S3 directly in the browser. Now I will demo the in-memory cache. This is the main cache console. In the terminal, I check the cache, no entries yet. I click view several times to fetch the images. Back in the terminal, I query the cache. 3 keys are stored, each pointing to images S3 URL. From the app logs, the first request meets the cache and take about a millisecond. Cache reads drop to 0.3 millisecond. Now I will demo connector sign-up and confirmation. This is my user prod in AWS console. Here are the current users. In Postman, the best URL point to my custom domain. I code sign up with my Qt email. Back in the console, after refresh, the new user showed unconfirmed. I copy the verification code from email and call confirmed sign up. Next, I log in with username and password, connector return ID, access, and refresh tokens. Reload the user table. The status changed to confirmed. Both file and job are protected. If I call them without an access token, it returns 401. Now I log in to get the access token. The browser saves it in local storage. Next, I will demo connector federated sign-in with Google. On the login page, I choose my Google account. Click Continued, and I redirect back. Login succeeds. In the AWS console, I refresh the user pro table and see a new user created from Google. In Connector app client, you can see my allowed callback URL include the custom domain. The Google Cloud Console, I set the authorite redirect URL to the Connector callback. In Connector social identity provider, Google is enabled with client ID and secret. Next, I will show Connector group for access control. In the user group, user KUAN is in the user group only. I log in as KUAN in Postman. I use the owner ID as a parameter. The API returned 403 forbidden. In the web app, the user can only see their own files, and the recruit button is disabled. Now I log out, add the user to the admin group. Then log in again. Now use owner ID as a parameter. Return 200. Admin can see other user files. The recruit button is enabled. The job moved back to queued. This is my Route 53 record console. Now I log in from the Postman request to custom domain. I do the same in web app with the same URL. In Route 53, my subdomain points to API Gateway custom domain. In API Gateway, the custom domain is mapped to my API stage, which forwards to my EC2 instance. Next, I will demo parameter store and secret manager. In parameter store, I keep no secret config, catch URL, cognito settings, the S3 basket name, and my machine learning model path and type. I opened catch URL. You can see the full URL for the catch service. The app reads those values at startup. In secret manager, I store secrets, database URL, and cognito client secret. I click retrieve secret value to show the DB connection. It contains the username and password. I built a config module that abstracts AWS parameter store and secret manager. It fetches values by key and loads them into a type setting model. I declare two constants, AWS region and SSM prefix. Everything else comes from parameter store and secret manager. On startup, for local dev, it reads .env file. In production, there's no .env. It loads parameter from parameter store first, then secrets from secret manager. Finally, it calls setting, load settings, which assemble the config and make it available to the rest of the app. Here's an example using the S3 basket name. On line 9, the file import config, it reads setting S3 basket, which comes from parameter store. That value is then used by S3 helper to put, get, and delete objects. For the database, I import config read setting database URL from secret manager. The value is used to create RDS Progress SQL connection. For Cognito, I also read setting Cognito's client secret from secrets manager. The backend uses this secret to enable Google federated login. Finally, this is my infrastructure as code with Terraform. I use Terraform to deploy all services. I run Terraform state list to show everything Terraform manages. Cognito, including user pool, client, domain, Google IDP, Route 53 records, the S3 basket, secret manager, secrets, and parameter store parameters. This proof the stack is checked and reproducible. Thank you.